I hope everyone's doing well. I am Mr. Ish. Thank you for joining me. We're looking here at first out of 3 videos which are related to polar geometry. A very important topic, and calculus is involved in terms of application related to polar geometry. In this video and 2 other videos after this, we're going to be looking at the following items. Let me show you. If you look here at a certain axis, polar axis, and the origin is also called a pole. In a polar system, it's called a pole, the origin. You can look here at a particular curve, and it could be a parametric curve, it could be a polar curve, whatever. And if you were to put a point on this, and we'll call it a P, you could designate it as R and theta. The R would be the distance, and it's usually called a radius, but it would be called a distance from your pole to that point. The distance here is your R, but again it's called a radius as well, because if you were to convert this polar axis into a regular Cartesian x and y system, you could generate a unit circle with relation to that and do right triangle trigonometry and show that the R is also for that particular point a radius as well for the unit circle that you would develop at that particular point for the polar curve. But it would be specific only to that point. As you change different points along your polar curve, you'll demonstrate new unit circles and then new values of R. But anyhow, we can call it a radius. What is our topic here? We're looking at this, and you know that to be psi. If you look here at a polar curve and you have your polar axis, your pole, you were to demonstrate a tangent line going through this point, tangent to your point on your polar curve. Here's a specific point T. There are 2 angles which develop. You obviously know there's a certain angle theta with respect to your axis and your radius. You can extend this axis out. We have 2 angles. One angle is this, we'll call this tau. We're not talking about that in this video, we'll talk about it in the next video. But in this video we're talking about this angle, which is right here, psi. Tau is the angle of inclination of your tangent line to your axis, but psi, the focus of this video, is the angle between your radius vector, which is this, and your tangent line. That's what it is. It's the angle between 2 items. What are those items? Your radius vector and your tangent line. That's what it is. What's the angle between this? We call that psi, and it's the focus of this. In this video we're going to look here at just a calculation. In the next video we're going to look at the calculation of this angle of inclination, but in the third video we'll look at the derivation of both of these polar geometry formulas. Formula 1, how does this formula come for the angle over here? Formula number 2, how does this formula come? How do you derive it for the angle of inclination? But that'll be the third video. We are looking here at this polar curve, and we'll do the calculation, the psi calculation for this. R is equal to 2 plus cosine theta. This right here, R equals 2 plus cosine theta, represents a representation of polar curves which are R is equal to A plus or minus B cosine theta, or you can say R is equal to A plus and minus B sine theta, where A is always larger than 0 and B is larger than 0. These represent a bunch of curves which are called lemma, and you can easily Google this. They're lemma. I will show you the representation with regards to this question, but this is what we're looking at. We're looking at the calculation of a specific angle between your point on your polar curve, which is this curve, the radius vector, and the tangent line which will be drawn at that point. Keep this in mind. Before I delve any further, keep one other thing in mind. If you look at old textbooks, calculus textbooks, this R value you see right over here is synonymous with this, which you know to be a rho symbol. These are both representing the same thing, radius or the vector, the distance from the origin to your point on your polar curve, and same rho. They both are used synonymously. It depends on old textbooks use this, new textbooks use that. If you were to graph this out, it would look something like this. It's a lemma for sure. A rough graph only, it would be coming like this, and it would come like that. That right there is an example of lemma, and it's representing this. I have a specific point over here at a certain angle with respect to your this axis, which is, let's say, pi over 3. We developed a point. I'm looking here at a 60-degree angle, and here's a point. Here's pi over 3, my angle theta. This point you know would be r comma theta. But at this particular point, I'm extending this out. I demonstrate a tangent. I can draw a tangent, and it's going across over here. The tangent intersects at this point T, but it can continue for infinity. This right here was angle tau. We're not focusing it on this video, so I'll erase it. But the angle psi is this angle right over here. The angle between your radius vector from your pole, your origin to your point P, and the tangent line, as you see over here, from point T up to point P. So that's what it is. We're looking from OR. This right here is having a certain angle as it intersects. It intersects with what? It intersects with your tangent line. Your tangent line is right here. We'll call it PT. P and T. That's your tangent. What is the angle in between? That angle in between is here, this, and we have to calculate it. The formula you want to be aware of is this. The tan of that angle, psi, is equal to what? It's equal to this. Your radius times d theta over dr. The derivative with respect to the theta. Now, if you shuffle things around, it can become easier to comprehend that. Tan of this angle, psi, is also equal to r over d r over t theta. Now what you're saying is you're looking at the r divided by the derivative with respect to r, because if you were to flip this around you would end up here. This right here is your formula. I'm just showing you a way to circumvent that formula because it will be easier to look at it that way. This right here is also equal to r over r prime, and these are a bunch of different ways you can do your calculation. You can say tan of that angle psi, the intersection of your tangent and your OR, your radius vector, is equal to r d theta or dr, or is equal to r divided by radius derivative as you see over here. So let's look over here. How will we do this calculation? I have everything already provided. I'm erasing this because we don't need to see this representation. You know exactly what we're looking at. The angle psi is what we're calculating. So how do we go about it? Look over here at the formula. I have a tan of an angle psi. I'm calculating that. I need to know r. I need to know these items. If r is equal to this, what's r prime? It's equal to the derivative of this. 2 is a constant, it goes away. Derivative of cosine theta is a minus sine theta. But I already know what theta is. It's pi over 3. If I were to do r with respect to theta, which is r with respect to pi over 3, what am I getting over here? 2 plus cosine of pi over 3. You know cosine of 60 is a 1 over 2 from your trigonometric ratios. It's equal to 2 plus 1 over 2, which is equal to 5 over 2. What if I were to do r, the derivative with respect to the theta, which is pi over 3? What am I getting? I'm doing here a minus sine of a pi over 3. You know that to be from trigonometric ratios. This right here is 60 degrees. You're looking at a root 3. Here's a 2 and 1. You're looking at a sine is a root 3 over 2, but it'll be a minus root 3 over 2 because the derivative brought in a minus root 3 over 2. We have everything we need to complete this. I'm looking here at the tan of this angle psi is equal to, I'll focus right at this formula, r divided by r prime. I have r which is equal to 5 over 2. I have r prime which is equal to this because I plug in the values. I have over here 5 over 2 divided by minus root 3 over 2. The denominators will cancel out. Your answer here will be minus 5 over root 3. But this represents here tan. You can actually calculate the angle by pushing the tan on the other side. We have the formula here. I'm erasing it because we now know it. We know the formula to be r divided by the radius derivative. Tan psi is equal to this, and then psi is equal to r tan, or inverse tan of minus 5 over root 3. And then we'll bring out our calculator and bring it to effect. For understanding or better appreciation for our answer, let's put the calculator on the DEG mode. We'll do 5 divided by root 3. Bring in a minus and then do inverse tan, and we have here minus 70.89. Our angle here is going to be a minus 70.89. If you think back to the representation, you know you're not going to have an angle such as that because our representation was this. This right here was angle psi. Here's my point P part coming off from here curve, but you have to do the reference angle with respect to 180. Bring it with respect to 180, because if you were to extend this, right, you're basically looking at that angle. We're looking here at this side. Bring it with respect to 180. When I add this to 180, I'm going to get my actual value is 109. This angle right here will be 109 degrees, and it will be correct. You always have to be wary of these adjustments at the end because we have a negative coming through here. It makes the value negative. You make it with respect to your horizontal reference, a continuation of your vector, add it to 180, and your angle will be 109.1. It will be a correct answer. So now this is done, let's look here at just a recap. When you are looking here at any polar curve, and let this be a polar curve, here's my origin, here's a specific point on that polar curve, point P. You can demonstrate a tangent line, and we'll call this T. My point of intersection here is T, but we'll call this segment right here PT. That's my tangent line. I have this O, I have this R. We have here a certain angle which demonstrates, and that's your psi. That's the focus of this video, and we've determined it to be. But the focus of the next video will be this. How can you determine that? And it will be called a tau. Then the focus of the video after that will be the derivation of these formulas. This formula you've seen already. You know this formula. Tan of psi is going to be equal to r d theta over dr, or when you shuffle things out, it's equal to r divided by r derivative. This right here is a formula. We have to learn how to derive it. There's a specific formula for this. We will learn that as well. But the focus of this video was psi, the angle that. And remember, when you're doing at this formula, it's always tan of psi. You have to take it to completion by pushing the tan on the other side, so you can actually get to your value. Otherwise, you're just looking here at a tan of a psi is equal to a particular value, but it doesn't give you the exact value until you push the tan on the other side. You will remember, as the very final point of this video, the psi angle represents the intersection of the OR vector and with the tangent line vector at your particular point P. Always at a particular point on your polar curve. Thank you for watching.